All right. Welcome back to Daily Math Concepts. What we're looking at is AdMath 2023. We're actually looking at um, question 6. All right. So this is the statistics and probability question. So it says the following stem and leaf represents the scores out of 80 of students in an additional math exam. All right, so we see the stem and the leaf. We normally call this part the stem, and over here we actually have the leaf, right? So it says, the first question says, write the raw data set that used to construct the diagram. So they want to know if we're able to interpret what this is. Remember, for the stem, this is 3 with a 0. That means there's a 30. So there is a 30, there is a 33, there is a 37. So these are like the ones and these are like tens. All right. And then apart from that, we had a 42. There was a 44, 46, 47, 49. All right. So we have those. And then we had 51. Then we have 53 2 times. There is a 56. There was also a 60, 67 2 times. And the last two, we had a 71 and a 79. All right, so there it is. So that's the raw data set. All right there. Understanding how the stem and the leaf operate. The B part says, determine the following measure, right, for the data set. The median. The median is the middle term. There are 17 things here that I line up in order. So if I have 17 terms, I'll have 8 on one side, 8 on the other. The 9th term, should say, will be in the middle. Term 9 will be right in the middle. 8 on one side, 8 on the other, term 9. So basically, I'm going to count to the 9th. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my 9th term. So that's the median. It's in order from lowest to largest. So the 9th is in the middle. So my median is 51, right? So I was able to pick up that. The mean. The mean is when we add up everything and we divide by how many of them. So we just simply employ some addition. So I'm going to be adding, matter of fact, let me just quickly take this. So we're going to take these, right? We could take these right here. All right, let me take them off. All right, so we're going to find our mean. So we want to add these up. We're going to divide everything by 17, right? So 30 plus 33 plus 37 plus 42 plus 44 plus 46 plus 47 plus 49, 51, 53 2 times, 56, 60, 67 2 times, 71, 79. So I'm getting 885 over 17. Let's divide that by 17. So I'm getting 52.06. All right, 52.06. That's my mean. So the mean score for me was a 52.06, or we could say 52.1, right? Whichever one we want to write. All right, good. Next question says the modal score, the one that occurs the most. All right, so the modal score will be the one that occurred the most. I'm seeing a case where I have a bimodal. 2 things actually occurs the most. We're talking 52, 53, and 67. We saw those 2 times, right? 53 and 67. So I actually have a bimodal situation where 53 as well as 67. All right, so this case is a bimodal, right? It's bimodal. There were 2 things that were equally occurring the same number of times, 53 and 67. All right, looking at this other question, it says, given that for the data set, the sum of the x square was 48,999. The sum of x was 885. Find the standard deviation of the data set. So they give us the formula to find the standard deviation. So basically, we're going to substitute. The sum of x is 48,999. I'm going to minus x squared, which is 885 over. So we want to square this. And this must go over n. It was 17. And then all of this will now be divided by 17 minus 1. So, and then we're taking the square root of all of that. So we take our time to work these out. I'll write back this part for now. I'm going to work out 885 square. If I divide that by 17, I'm getting minus 46,072.05882. And then all of this will now go over 16, and then I take the square root, right? All right, continue working. 48,999 minus 46,067.05882. Divide this by 16. All right, so I'm taking the square root of 183.25. And I'm getting my standard deviation to be 13.54. All right, so that's my standard deviation right there. Formula was given. All we had to do was just to drop it there and continue working. All right, let's go. All right, next question. If a student needs to score at least half the total marks to pass, right? Determine the probability of a student failing the exam, given the answer to 2 decimal places. So we want to know the probability of a student failing. So the context of the question, they're telling us that you need half to, so it's a half to pass, right? The test was the total marks was 80. All right, so half of 80 is 40. This is to pass. So if you score 40 or more, right? So we're talking about to pass, you want to score greater than or equal to 40 and you pass. So the question is saying here, determine the probability of a student failing. So you're talking about somebody who is getting 39, but let's just say if you get less than 40, you fail. All right, so this is to fail. So you want to know the probability that a student will fail. How many of them from that data set would have gotten less than 40? So we go back 3 persons here. Less than 40, 3. So here it is. Probability that they'll fail is 3 out of 17, but they want it to 2 decimal places. So 3 divided by 17 would have given us 0.176470588, but they want 2 decimal places. So answer is 0.18, right? So that is the probability for a student to fail. That's getting less than 40. Next question says, given that a randomly selected student, right? Given that a randomly selected student has passed the exam, what is the probability that the student score over 60? Give your answer to 2 decimal places. Over 60. This never said 60 and over. Let me read again. Probability that he score over 60. All right. Now, given that, here's the condition. So this is a conditional probability, but look at this. Given that a randomly selected student has passed, so we're going to be selecting from those who has passed. Now, if we have 17 and 3 fail, it means then that 14 had or has passed. So we're going to be selecting from 14, right? So we're going to look within this 14 to see how many of them score over 60. So I'm not taking 60 because it says the students score over 60. So let's see those who score over 60. Let's see. 67, 60, 67 2 times, 60, 71, and 79. So over 60 would have been everybody here. These. So we have 4. 4 over 14, but they want it to 2 decimal place. And I'm getting 0.28571428 to 2 decimal place, 0.29, right? So the reason why I didn't pick 5 is because they didn't say what is the probability that the student score over 60. 60 is not over 60, so this is not a part of my students. I'm looking for those who beat 60. So we got in 4 of them out of the 14, and that is 0.29 to 2 decimal place. Based on the given stem and leaf, describe the distribution. So when they said describe, you want to look on how it is skewed. Is it a normal distribution? And when we have a normal, there's a balance in the data. The left side is equal to the right side. There is a case where it could be negatively skewed. That means the bulk is up to this side so the bulk is up to that side. And then there's a tail heading down to the left. So this one is negatively skewed. And when it is positively skewed, the bulk is up this side and then the tail heads to that way. And you have most of it over to the right, positively skewed, right? So we can quickly take a look to see where is our mean, our median, and then you could see what happened. So we could quickly go back, right? So we could quickly go back here. Our median was 51. So your median is somewhere here. Median is somewhere here, right? But then again, you're looking at those who pass, right? So those who pass the test. So let's look on the scores. We have 30, a lot of these scores. Okay, so if I should quickly do this right here, let's just do it right here. These scores are very small up to this. So we have a lot. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So from 50, we have a lot of them on this side. And then we have less going that way. So if this is about 51, all right, there are a lot. We have We have way more than half. So we have more of the data set over this side, more. We have more of them to the left. And then that means the tail is going this way. So in other words, then not a lot of people get in the 70s and the 60s. We have more in the 30s, the 40s, which is behind this 51. So then this is going to be a positively skewed data. You understand, where the tail is heading to the right. So go back. We're talking about a positively skewed data. So we could say this data is positively skewed. All right, your friend suggested that a bar graph or histogram could be used to represent the data. Advise your friend on which is the better option, giving one reason to support. Now, we have bar graph and we have bar graph and we have histogram, right? Now, the main thing is that we want to know which graph represent what. Bar graph used to represent discrete data. We're talking about data that can be counted. Now, histogram represent continuous data. And this is data that can be measured. So there's a difference here. We're talking about scores of a test that we can literally see who gets what. So stuff that you can measure are like time, yeah, height, length, those sort of stuff. And we're not dealing with that. So in reality, I would suggest that we use the bar graph here. And the reason is that we're dealing with discrete data can be counted. How many persons score 57? How many persons score 60? That sort of thing. So it's a bar graph that is the better option of the two.